Today our topic is gravitational field. Gravitational field uh, is a term which basically defines area, and it defines a particular area. To define gravitational field, we shall use a figure which is figure of Earth. Let's say this is Earth. Its mass is denoted by capital M and E, mass of Earth. Let's say this is center of Earth. Then we know that Earth pulls every object in its direction. For example, if an object is thrown upward from this point in this direction, then Earth pulls it in this direction. If we throw an object from this point in upward direction, Earth will pull it in downward direction in this way. So we can say that pull of Earth is always towards center of Earth. Earth is always giving an impression as it is pulling the objects towards center of Earth. So we can mark the direction of its force as this is the direction of force of Earth on objects which are around Earth, and Earth pulls them in its own direction. But remember that this force of Earth is up to a specific limit. For example, if someone is standing here and he moves upward, then uh, it's not like that he's moving away from Earth and he moves an infinite distance. Even then, Earth will attract it. But attraction of Earth is up to a certain limit. Let's say that I mark this limit with this dotted line, that Earth can pull the objects from the boundary of this dotted line towards it. But when these objects move away from uh, Earth more than these dotted lines, then Earth is unable to pull these objects. So if an object is thrown in upward direction, then Earth will pull it. But until and unless that object is within this dotted line perimeter, if it is outside, if it goes outside, let's say an object is present here, then Earth will not be able to pull that object, because with increase in distance, pull of Earth becomes weak, and with further increase in distance, there comes a point where its attraction becomes zero. So we can say that this is the specific region around Earth in uh, which we have shown by arrows. This is the region around Earth in which Earth can pull the object. So this region is known as gravitational field. It means that area is known as gravitational field. That area is known as gravitational field in which Earth is able to pull objects towards its center. So this is the area between these two circles, between the boundary of Earth and between this boundary, that Earth is able to attract objects. So this area is known as gravitational field. So you must be able to understand that gravitational field is an area. Which area? In which Earth can pull objects towards its center. The force of Earth is always directed towards center, but what will be its value at the center of Earth? At the center, value of this force is 0. It means if an object is placed here, it is attracted towards this point. If it is allowed to move towards center of Earth, at center, force on this object will be 0. So we can say that at the center of Earth, value of G is also 0. If force is 0, then G is also 0. What is this G? It is gravitational acceleration, which means acceleration on this object, when it is placed at center, then its acceleration will also be 0. one very important question, that if an object is allowed to move towards center of earth in such a way that, let's say, a pipeline is provided to this object in this way, and it is allowed to fall down, then it will fall down because earth is attracting it towards center. But will it stop here? It will not stop at this point O, center of earth, but it will carry on its motion. Why? The force is zero here, but this object is coming with very high momentum. For example, if someone is running very fast and you're asking him to stop at this point, he's coming at high speed from here. He will not be able to stop at this point. He will carry on his motion because of his momentum. Same is the case here. Due to high momentum and due to inertia, that object is moving with uniform velocity, then it will carry on its motion with uniform velocity. So this object will not be able to stop here. It will continue its motion. When it will reach this point, then earth will again attract it towards center, then it will again move in this direction. But due to inertia, it will not stop here, it will go again to this point. It means when an object is allowed to move uh, through the center of earth, then it will always move to and fro. It will possess vibratory motion about the center of earth. Now we shall define two or more terms related with earth, and we shall also write Newton's law of gravitation for earth. If an object is placed here, let's say its mass is m, then what will be the formula for Newton's law of gravitation? We have written Newton's law of gravitation as F is equal to G m1 m2 divided by d square. If an object is placed here, then from center to this point, distance is equal to radius of earth. This is radius of earth from center to its boundary. So here distance is equal to radius. So we can write this law as, for earth, F is equal to G m1 and m2. Here are two masses, me and m. So we can write it as G me m divided by, what is the distance here? R square. So this will be the formula for a force when object is placed on the surface of earth. Now we shall define that what is a field force. What is a field force? Field also means region. All those forces are called field forces whose which act in a specific region. So we have seen that this force of earth is acting within specific region. It is acting inside this boundary and it is acting outside its center. So the force of earth is, as the force of earth is acting in a specific region, so it is also a field force. Field force means that force which has certain boundaries, that force which is acting between in a specific region, that force is known as field force. So Earth's force is known as field force. What is meant by gravitational field strength? It is also a very important term. Gravitational field strength. If a mass is placed here, then what will be the quantity of force on this mass? If mass is increased, another mass is placed here, which is slightly bigger, then what will be the force of earth on this mass? This measurement is known as gravitational field strength. That is, force on a mass in the gravitational field. Force on the mass in the gravitational field is known as field force. That what quantity of force earth is exerting on different masses in the gravitational field, that is known as gravitational field strength. For example, Earth is attracting this mass by a force of 10 Newton when this mass is 1 kilogram. So it will be written as 10 Newton per kilogram. If Earth is attracting a force of 20 Newton on this mass, which is 2 kilogram, then again force will be 10 Newton per kilogram, because if it is 20 Newton on 2 kilograms, then it will be half on 1 kilogram. So the force of Earth on every 1 kilogram mass of an object, that is known as gravitational field strength. If an object is placed close to the surface of Earth like this one, then this value of this force is remember that gravitational field strength is written as F over m. It is denoted by force per unit mass, which will be equal to 10 Newton per kilogram if an object is placed on surface of Earth, and its quantity goes on decreasing when object is moving away from Earth. What is the origin of this force? If it is zero at center, remember that origin of this force of Earth, that is gravitational force, it is unknown. That is why it is a basic force. So remember that there are four basic forces, out of which one is gravitational force. Gravitational force is a basic force because its origin is unknown. So I'm writing its key point here, that it is a basic force because origin is unknown and it is natural force. It is called basic force because it is natural force and its origin is unknown. Can this gravitational force repel objects? Like magnets, they repel like poles. Gravitational force never repels objects. It is always attractive force. So this is also very important point, that it is always an attractive force. So these are a few important points related with this topic, and it's a very small topic, but it is very important to understand using Newton's law of gravitation. Thank you.